So, last year when you were learning differentiation, the big skill that you learnt was finding the tangent to a particular line or curve or point or whatever at a certain point. That was the big, huge, just about the only thing you learnt. There are a couple of other little things, but that was the major one. This year, it's a pretty minor one. So basically, because it's applications of differentiation, to get any, after those first three questions, which they're looking for, do you know, the three rules, the three new things, after those three questions, the other questions, they all have to have an application. So this is one they like to pull in because it's supposed to be easy, but really what they're still testing is whether you know how to differentiate or not. So I'm just going to go over what these are in the first place. So let's say we have a curve. I'm not going to draw a parabola today, I'm going to draw a cubic. All right. So at one point, so the gradient on this graph changes as you zoom along it, right? So here it's about 2, and it zooms up here, it becomes closer to 1, and then it goes to here and it's 0. Then it goes down here and it's really quite low negative, and then it gets high negative, and then it gets low negative again, there's 0, etc. Right? So the gradient changes wherever you are. So at one certain point is what we're interested in. This point here today. All right? So at this point, the gradient is equal to the tangent. Now what's tangent? A line, straight line, that touches the curve at one point and one point only. So that is the tangent to this curve at that point, whatever it happens to be. K. All right? So the tangent of the curve will be exactly the same as the tangent of this line. Now, the normal is perpendicular. Good. So, try to get it perpendicular. This one is the normal. And there is a relationship between these two gradients. The relationship is good. They're the negative reciprocal. So if this one is mn, the gradient, and this one has the gradient mt, then mt times mn will equal -1. So when we say the negative reciprocal, that means that mt is equal to -1 over mn, negative reciprocal. All right, so we use always the gradient of the tangent to find the gradient of the normal. Okay, so last year you got nice polynomials to do this with. This year you're more likely to get something like this. Find the equation of the normal to y equals sine 3x at x equals 1/2. All right, so first thing you have to do, because it's in all of these assessments, is you have to differentiate. So that part's easy, the differentiation part's easy. So we're after y dash equals, it's a present, right, chain rule. So we've got sine differentiates to cosine, 3x differentiates to, so I'm going to put the 3 in the front because it looks nice. But I could just as easily have written cos 3x with a bracket and a 3 at the end. So now I've differentiated, I need to find out what the gradient is. So this differential is called the gradient function. The first differential of any function is the gradient function. All right? So we can put any point in this wonderful curve of sine 3x. I have no idea what that looks like, but whatever it is, we do have an idea what it looks like, don't we? Because we've done our trick. So there's 3 times as many in the space of 1, so a very wiggly line, right? Going like this all over the show. We can find the gradient at any point on that by just substituting a value into this. Okay, that's what the gradient function does. So we're going to put a half in here. So the gradient at x equals a half is y dash cosine 3 over 2. Right, 3 over 2, 3 times half. Put that in our calculator in radians, because remember we only deal with radians now. So just check it's in radians first. Yep, so 3 cosine 1.5 equals. I get 0.2122. Anybody want to agree? Good. Okay. 2122 to 3 dp, that'll do me. Right, nowhere yet close to actually finding the answer because we've got to a kind of an achieved level at level 2. We need to keep going. So our next job is, because it's the normal, which I would have highlighted if I was in the exam, I need to put this in. So I'm going to find out that, remember these are interchangeable, mn, the gradient of the normal, equals negative 1 over 2.122. Now, you do actually have a button on your calculator that will do this without having to type it in. So I've already got this big, huge, long thing. If you use the thing above the right-hand parenthesis, right-hand bracket, you can just push that, shift that, and it will give you 4.7122. And then you just have to remember to make it negative. So knowing how to use all these buttons on your calculator are actually quite helpful as far as saving time. 7.122. Now I've got more decimal places. All right, so what next?
Assuming 0, like 2,
Okay. Yes, I do. Good job. Let's always make a mistake. 0.2.
Yeah, we're just doing
Good that you guys put it in your calculator. Right, still does equal that, and the reason it equals that, and I wouldn't have lost any marks, is because I didn't type it in again. I used the value my calculator told me, which was this one, so my negative inverse is still this. Bonus. All right, here's my gradient. What am I going to use next? I've got an equation of a normal. What kind of thing is this? It's a straight line. All right, so along with the gradient, I need a point that's on the curve. So I'm going to use the point that I've been given so that I get it right. So I need to now know what the y value of the coordinate is. So y equals sine 3 over 2. So I'm substituting in here. So again, pick up my calculator, put sine, and 0.99749, la 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 la. 0.99 will do, because the next one's a 4. If I rounded it, I would have ended up with 1, but that's all right. So this is my value. My equation that I'm going to use is, go, y minus y1 equals in bracket x minus x1. I think you don't have to remember that. I'm pretty sure it's on the formula sheet, but it may not be. But we need all those things. Yeah, you would have had it for your calculus exam last year. It would have been the only formula on your formula sheet. So we now have an m, we have a y1, which is that, and an x1, x1, y1, and so we get our answer, which is bracket x minus a half. Which isn't a very nice way of writing it, so we probably should tidy this up. y equals negative 4.7122x, and then grab a calculator, do half times 4.7122 equals, and then add 0.99. 3.34? Somebody agree? Anybody done it? 3.3461 I get. Plus 3.3461. So that times that, 4.7112 times negative a half, so it's a positive, and then add on 9.99. All right. So